This is 6.5 in Advanced Algebra 2 today. Today we're simplifying radicals, which is what we did last time. We simplified radicals, but everything came out just real pretty last time. Everything was either a perfect square underneath the square root symbol, everything was a perfect cube underneath the cube root symbol, and etc. Today, not so much. We're just going to kind of dive right in. You see number 1 right here. Notice the instructions. Do not use a calculator. This is hard enough to do at first with a calculator, let alone that we are asking you to do it without a calculator. So if you want to have your perfect note card out today, we can have it out if you want it. But realize that you won't get to use that on the test. Okay? We need to kind of practice and get better. And some of the things that you've been hearing your math teacher say for the past few years of how your number sense is pretty shaky, you're going to find that out today if you don't have good number sense. So we want to simplify all of these radicals. For example, let me go back here. You've seen us simplifying the square root of 50, correct? We need to find the biggest perfect square that goes into 50 evenly. And remember, you don't get to use a calculator. The biggest perfect square that goes into 50 evenly is 25. How many times does it go in there? And that simplifies to be 5 square roots of 2. We're pretty comfortable with that. You've done that a few times, you know, and last year you did it, should have done it in Algebra 1. Showed you, if you wanted to simplify this, see, that's the cube root of 16. You all realize that 16 is not a perfect cube. We want to find the biggest perfect cube that goes into 16 evenly. So that's why we've been asking you to know those numbers. Like if you was to make a list of perfect cubes, it'd be 1, 8, 27, and etc., correct? What's the biggest perfect cube that goes into 16 evenly? So we split it up into 2 radicals, and the trickiest part about this is you may understand it, but you put the wrong index up here sometimes. It's like, oh, you put square root symbols. You need to put cube root symbols, right? You got to put that correct index. Does an 8 go in there? How many times does it go in there? And we're going to have 2 sides today. This is the perfect side, because everything over here is perfect, right? We're doing cube roots. Isn't 8 a perfect cube, correct? This over here I just call the non-perfect side. Sometimes I call it the scraggy side. It's not perfect. What is the cube root of 8, my friends? It is a 2. This cannot be simplified any further. And there's our final answer right there. So if we go to number 1, first question, what kind of root do you have? Number 1. Interesting. Some people do think that that's a 5th root. Is that 5 a coefficient, friends, or is it a little index? That's a coefficient, right? The little index, you can see how small they are? Like that's a cube root right there and all that up right above the little radical symbol. So on the little shelf, if you will. All we got to do is simplify that radical. So let's do it. We're going to go old school. We're going to split it up into 2 radicals. You're going to realize we want to do that. Find the biggest perfect square that goes into 54 evenly. And oh yeah, no calculator. Right. So get that done for me. You don't have a list in front of you. You don't have a calculator. You got to figure it out. 9. How many times does 9 go into 54? 6 times. You realize that the number on the left has to be a perfect whatever root you are here, a perfect square, correct? So now, the next thing we can do mentally, because you should know what the square root of 9 is. What's the square root of 9? Times 5? 15 square roots of 6. Are you with me on that? This guy, what kind of root? Let's split them up into 2 square root symbols. And I like to roll one concept at a time. There are constants in there, there are x's in there, there are y's in there also, correct? One thing at a time. 75. What's the biggest perfect square that goes into 75 evenly? 25. How many times? Do you see how I dealt with both parts? I did the perfect thing, and then I put the leftovers over there, right? 25, then 3. Now let's deal with the x's. Since this is a second root, you want to know, well, is this even a perfect square in the first place? Is this power a multiple of that index right there? So isn't x to the 4th itself a perfect square? The whole thing goes over here. All the x's are perfect. Cool? The y's. 7. 7 is not a multiple of 2, correct? So we need to just get as many y's as we possibly can. We need to work down to the next multiple of 2 from 7. Isn't that a 6, right? If you go lower than 7, isn't 6 the first number you come to? That's a multiple of 2. So we can put 6 y's over here. You with me on that? And how many y's go in the non-perfect side? Just 1. Is everyone down with that so far? Split it up is all it did. Cool? Now everything over here, woohoo, that's perfect, correct? Let's square root that. Doesn't that turn out to be 5x squared y cubed? Correct? Because the power over root trick, right? Where the exponents came from, is everyone down with that? 4 divided by 2. You all right with that? Okay. And then this guy comes down. That's not perfect. Nothing's going on there. Groovy? Next one. What kind of root? Square root. Split them up. Find the biggest perfect square. That goes into 32 evenly. Doesn't 16 go in there evenly? And these are things you need to be practicing. We got to move a little fast today because of how many things we have to cover. But do you at least understand what I'm doing, right? And you might have to spend a little bit of time thinking these things through. And then x to the 8th. 8 is a multiple of 2, correct? That means the whole thing's perfect. That's all perfect over there. Rock and roll? So then this we will square root 4x to the 4th square root of 2. Rock and roll? Why don't you pause the video and give number 4 a shot for me. So it's a square root. 12 gets split up with the 4 and the 3. C to the 6, that whole thing is a perfect square because 6 is a multiple of 2. D to the 3rd, not all of it is a perfect square. I can take 2 d's over here on the perfect side, correct? And there's 1 d left over there. Is that cool with us? Then 2c to the 3rd d times the square root of 3d. Righteous? Pretty simple so far. Feeling good? Next one. Watch the root. What kind of root is it? Cube root. Split it up into 2 cube root radicals first. Well, I guess I should really say this. You don't always have to split it up into 2 cube root radicals. First, you want to look at all the stuff underneath there and see if they're all perfect cubes or not. Is 27 a perfect cube? Is y to the 12th a perfect cube? Is 12 a multiple of 3? Yep. Is z to the 7th a perfect cube? Since there's not perfect cubes in every little guy right there, you need to split them up into 2 dudes, right? You said 27 is a perfect cube. That whole thing comes over here. You just told me that y to the 12th is a perfect cube. Doesn't that whole thing come over here? Z to the 7th, though, is not. How many z's can I put underneath my cube root guy, though? I need the next multiple of 3 less than 7, right? And isn't that a 6? So I can put 6 of them over here. And how many leftovers do I have? Just that 1 z over there, z to the 1st. And then just be careful. We're cube rooting now. So that would become 3 y to the 4th z to the 2nd times the cube root of z. Yes, sir, Bob? And make sure you cross your z's. Next guy, what kind of root? Cube. So that negative under there, who cares about him, right? It can happen, right, because it's an odd root. Is everything a perfect cube? Is negative 16 a perfect cube? So we need to split them up. What's the biggest perfect cube that goes into 16? 8. Bring the negative on the perfect side, though. Put the positive on the non-perfect side. So pull a negative 8 out. Variable-wise, I think we're pretty golden. A's, how many are you pulling on the perfect side? 3 of them. And that means there's how many left over here? 2. And then b to the 6th on the perfect side and b to the 1st on the non-perfect side. Does the split up make sense to you? Now it's cube root time. That'd be negative 2ab squared cube roots of 2a squared b. Now let's talk a little bit about how you know you simplified your variables completely. Like when it comes to the numbers, that's one thing. The variables, though, If you look over in the non-perfect side, on the non-perfect side, I want to say that one more time. On the non-perfect side, every one of these little exponents in here has to be less than that root right there. Is 2 less than 3? Is 1 less than 3? That's how you know you simplified it completely. For example, if this was a 4, don't you really realize that you have too many b's in this situation? You could have pulled an extra 3 of them out of there because there's 4 in there. You're looking for multiples of 3. So this guy always has to be less than the index on the non-perfect side. Cool? You see over here, they can be bigger than that because they're perfect, and you can actually cube root them. Sweet. Fourth root time. Do we need to even pull it apart? Is 32 a perfect fourth? Like I said, we're shaky at first. We don't know that note card as well as we think we do, right? Is 32 a perfect fourth? Nope. So we got to pull them apart. Don't forget your little indexes. Okay? Find the biggest perfect fourth that goes into 32. Like I said, if you got to look to your note card today, look to your note card. We need to practice and get better. 16, right? Isn't 16 a perfect fourth? And it goes in there twice. The variables we dominate now. How many a's you putting on the left side of the perfect guy? A to the 8, and then there's 1 left over here. And 20, can all 20 of them stay over on the left side? Because 20 is a multiple of 4, right? Good? Then, oops, we might get optical illusion because 16 is one of them crazy numbers. 16 is a perfect square, but we're not trying to square root. We're trying to fourth root. The fourth root of 16 is not 4. It's how much? 2. A to the second, b to the power over root. We need to divide 20 divided by 4, 8 divided by 4 situation. Then this guy comes down. Check your variable. Is the exponent on your variable less than the index in this situation? Yep. One more. One more. Why don't you pause the video, give him a shot. Got me some fourth roots. 16 is a perfect fourth. A to the 24th is a perfect fourth. And b to the 13th is not, but 12 of them can come over here, and doesn't 1b have to go over there? Right? Then all of this, 2, a to the 6th, b to the 3rd, fourth root of b. The cake now, baby. Adding radicals together. You treat a radical like it's a variable. My friends, 2x plus 3y. Can you add those together, 2x and 3y? Not like terms. But what if I add 2x plus 3x? Can you add those together? That's 5x. So if you had, say, 2 square roots of 2 plus 3 square roots of 5, and you're treating radicals like they're variables, can you add those together? Can you add radical 2's and radical 5's together? No, you can't. But what if I said 2 square roots of 2 plus 3 square roots of 2? Aren't these both square roots of 2's? If you had 3 square roots of 2 and 2 more square roots of 2, you have a total of 5 square roots of 2, correct? So all we got to do is simplify these radicals and see if we have any nice, neat guys. I believe we'll just do it like this. Biggest perfect square that goes into 50 is how much? 25. How many times? 2 times. Plus 4. Then we got to split that 500 up. Biggest perfect square that goes into 500 is 100. How many times does 100 go into that? And minus 6. Sorry. Come on, pen. Minus 6 times 2 radicals. Biggest perfect square that goes into 125 is 25. How many times? Cool. Now I'll do a little bit of double cleanup. I know that the square root of 25 is 5. Take it times 2 more, and then you get 10 square roots of 2. Plus square root of 100 is 10. Take it times that 4, and you get 40 square roots of 5. Minus 30 square roots of 5. Y'all cool with where the 30 came from? Do you have any quote-unquote like terms in this bad boy? You got some radical 5s. 40 radical 5s take away 30 radical 5s is how many radical 5s? Yep, 10 radical 5, but that 10 radical 2 at the front didn't get to go away. It doesn't matter that those coefficient type guys are the same. It's all about the radicals. Radical 2s and radical 5s are different things. Just like 10x plus 10y, you don't get to add those together and say that that's 20 or anything like that. It's 10 square roots of 2 and 10 square roots of 5. Let's jump over to 19 and call that our last one of these today. Simplify all of those radicals on 19. So, you can watch me. All of them are radical 5s. You must use the order of operations and work from left to right, though, when you do your adding and subtracting. So you have 2 square roots of 5 plus 5 square roots of 5, which is really 7 square roots of 5. Take away 3 square roots of 5, and don't you have 4 square roots of 5 in that situation? Do you understand what we're doing on these problems? Piece of cake. Let's go to something like 22 right here. You see we're going to take radicals times radicals. You can do that. I highly advise, if you see some radicals that can simplify first, to simplify them first, especially since it's non-calculator type stuff. So see this square root of 60? Simplify him. Find me a perfect square that goes into 60 evenly. And it's 4. How many times? Take a wild guess how many times it'll go in there. 15 times. Right? So I just wrote him above it a little bit, and don't I really have 2 square roots of 15 right there? Isn't that what that is? Square root of 4 times square root of 15, 2 square roots of 15, and plus 1 more square root of 15. Can we add those together in what's inside the parentheses? Square root of 15 plus 2 square roots of 15 is how much? 3 square roots of 15. Cool? So I simplified it as much as I could. Now, numbers times numbers is how you roll. 2 times 3 is? Radical 3 times radical 15 is radical 45. Then, of course, we go so far, and we got to see, can the square root of 45 simplify it all? Perfect square that goes into 45. 9. So that becomes 18 square roots of 5. If you wanted to separate it, I told you you can skip some steps in simplifying square roots. I do not advise doing that for cube roots or fourth roots or anything like that. Separate them out, okay? But square roots, if you want to skip some steps. Number 23, just give you some advice. Look what happens if we multiply them together first. What kind of root do we have? Square root. If you took that 8 times the 2, what would you get? A perfect square. If you took c to the 3rd times c to the 1st, you would get c to the 4th, which is a perfect square. And you take d to the 5th times d to the 3rd, you'd get d to the 8th, which is a perfect square. So let's multiply these together. You got to take the 6 times the 4 times each other also and get the 24. And then you'd get radical 16 c to the 4th d to the 8th, right? You just multiply all that stuff together. And lucky us, that whole square root is nothing but a perfect square, just like your homework quiz today, piece of cake. It becomes 24 times 4c squared d to the 4th. And of course, we just got to multiply 24 times 4. We got to do it without a calculator. And if you need to jump off to the side, you do that. You know, if you got to jump off to the side, do it. And it's 56. C squared d to the 4th. Why don't you try 24 on your own? Watch your index, multiply everything together. Should get 6 4th roots of 16 x to the 8th y to the 4th. Right? When you multiply, I'm not done. I just multiplied them together is what I did, right? Look at everything underneath there. 16, is he a 4th? And all of these, 8's a multiple of 4, 4's a multiple of 4, aren't those all perfect fourths also? Lucky us. 6 times, just be careful with that 16. He's Mr. Optical Illusion, him and 64, right? There are all these different kinds of perfects. What's the fourth root? 16. 2x squared y. And then you multiply them together and get 12x squared y. Hang in there. Only got a couple more. It's not in difficult land anymore. 25. I would not want to multiply those two cube roots together without a calculator. I don't want to take 81 times 24, even though I could write it out. I don't want to do that. Why don't we try to simplify each one of them separately first and get some smaller numbers out of that? So 81. Is 81 a perfect cube? So we need to check it out. 1, 8, 27. Sure that 81 is not a perfect cube? 4 cubed is 64, right? And yeah, so 125. Let's work backwards. 125 is too big. Does 27 go into 81 evenly? Isn't 81 like to the fourth power, right? Isn't it 3 to the fourth, right? So wouldn't this be really 27 goes in there? How many times? 3. All I'm doing is splitting up Mr. Left guy. That's cube root of 81. How about 24? What's the biggest perfect cube that goes into him? 8. How many times? 3. So see if you can clean that up. You got a couple of perfect guys and a couple of non-perfect guys. You really have this. With me on the 3 cube roots of 3 times 2 cube roots of 3? Yeah? And then 3 times 2 is 6. Is the cube root of 3 times the cube root of 3 3? The square root of 3 times the square root of 3 is 3, correct? But what's the cube root of 3 times the cube root of 3? Check this out. What's the square root of 2 times the square root of 3? What's that turn out to be? Square root of 6. What's the cube root of 3 times the cube root of 3? It's not 9. It's the cube root of 9. Is 9